Okay, now we are going to solve inequalities. Last week we went over how to write them. This is for Tuesday, November 3rd. So first we're going to review equations. Inequalities are solved very closely like equations. So step one, we isolate the variable and coefficient. Step two, we eliminate the constant. With inverse operations. Once again, these are the same steps for solving equations. We're reviewing them and then showing how they're similar to equations. Step three, we then isolate the variable. Step four, we eliminate the coefficient with inverse operations. And step five is still, you can check your answer. So those were the steps for solving equations. We're going to follow them for solving this inequality. So we have 6x plus 6 is greater than or equal to 48. So step one, we isolate the variable and coefficient. So that's the 6x. We want that by itself. To do so, we move or eliminate the constant using inverse operations. It's plus 6. So we need to subtract 6. 6 minus 6 cancels. We're left with 6x is greater than or equal to 48 minus 6. We use this with 42. And now we have 6x is greater than or equal to 42. This means 6 times x. So we need to isolate the variable by doing inverse operations. Since it's multiplying, we're going to divide by 6. So the solution to this inequality is x is greater than or equal to 7. Meaning x could be 7, 8, 9, 10, anything bigger. So then don't forget step 5. We can check. We need to pick something that's bigger. So we have 6x plus 6 is greater than or equal to 48. So we figured out our variable needs to be 7 or greater. So since it can be 7, we can just plug 7 in. So we have 6 times 7 plus 6 is greater than or equal to 48. 6 times 7 is 42. 42 plus 6 should be greater than or equal to 48. 42 plus 6 is 48. So that's true because they can be equal. If it was just greater than, that would not have been a solution. So what do we notice? We notice that the steps for solving equations apply to solving inequalities. There will be something that changes, so keep watching. So now we have another inequality that's similar, but our coefficient is -6 this time. So we still isolate our variable and coefficient. Our constant +6, to eliminate it, we subtract it over to the other side. We get -6x is greater than 42. Notice the inequality symbol is only greater than this time. It's not also equals to. Next, we need to isolate the variable. Being multiplied, so we're going to divide by -6. So we get x is greater than -7. So we need to pick something that's greater than -7 then to check it. Because we can't pick -7 because it's not equals to. So we have -6x plus 6 is greater than 48 as our check. So we're going to pick something greater than -7. So let's say -5. Since it's a negative, -5 is closer to 0, so it's bigger than -7. -6 times -5 gives us +30. So then we have 30 plus 6 is greater than 48. 30 plus 6 is 36. It's greater than 48. But 36 isn't greater than 48. So that's not true. So what do we notice? The solution is incorrect. We picked a number greater than -7. We followed it correctly, and it's not working out. So here comes the different step. So this was our check. This is the problem. This was the solution that we came up with. So, second set of notes. We have 2 pairs of inequality flip-flops. The variable on the right flip-flop. The variable should always be on the left side. This just makes it easier when you're graphing. So if it's on the left, you can just graph how it is. The variable is on the other side. You must flip the direction of the inequality symbol when you flop the variable to the other side. Flip, flop. That's one way to remember to do that. So we're going to just rewrite these inequalities. We flip the sign, we flop or switch the variable number. So this is 400 is greater than x. That's the same thing as x is less than 400. It's still open to the same thing when you flip them. This is x is greater than or equal to 54. And x is less than or equal to -20. Still pointing at the variable. This is pointing at the variable. So that makes it easier when you're graphing. Okay, so here comes in why our solution was wrong on the front. This if you have a negative coefficient. So coefficient, as a reminder, is the number multiplied or divided with the variable. So if the variable is being multiplied by it, if it's being divided by it, that's the coefficient. So we're looking at is if it's negative. So if the coefficient of the variable is negative, you must reverse the inequality symbol when you multiply or divide. Both sides of the inequality by a negative coefficient. Why? A negative sign also means the opposite of. So it's the opposite of what you have. So you switch. If it was greater than, it's less than. If it was less than and equal to, it switches to greater than or equal to. So then we have 4 examples for solving. We have negative 9x is less than 81. So it's negative 9 times x. So we're going to do the opposite of that and divide. We're dividing by a negative, so we switch the sign from less than to greater than. And then 81 divided by negative 9 is negative 9. Next one, x divided by negative 4 is less than or equal to 20. Opposite of dividing is timesing by negative 4. We multiplied by negative, so we have to switch it from less than or equal to greater than or equal to. And then 20 times negative 4 gives us negative 80. Next two, we have negative 8 plus x is greater than 10. This is negative 8. So to get a variable by itself, we add 8 over. X is greater than 10 plus 8, 18. There was no negative with our variable, so that time we did not need to switch it. And the last one, we need to get negative 2x by itself first. This is a positive 5, so to cancel the positive 5, we have to subtract it. We get negative 2x is greater than or equal to 19 minus 5. Gives us 14. Well, it's a negative 2 times x, so we're then going to divide by negative 2. We divide by negative, so we must switch our sign from greater than or equal to less than or equal to. So this is just solving inequalities.